Hello everyone, welcome. In last class we have discussed about the what is resonance, definition of resonance, and how you have to draw the resonating structures, right? So today's class is just about stability of resonating structures. For suppose if you have two resonating structures, if you draw two resonating structures, then how can you know, how you get to know which resonance structure is more stable and which resonance structure is less stable, right? To know this, I have one trick here. So the trick is new negative charges. New negative charges are blasting. The trick is new negative charges are blasting. This is the trick. If you remember this, you can write the order of the stability of resonating structures in a very easy manner, right? Okay, what is O? First of all, I'm writing here. So the O means octet. So the first one is octet. All right. Next, nu means neutral. I will explain you what is octet, what is neutral, everything. O means octet, nu means neutral. Third one, negative charged atom. Negative charged atom nu, negative means negative charged atom on more electronegative atom. Negative charge on more electronegative atom. Negative charge on more electronegative atom. More electronegative atom, right? Next, charges. We have so many charges. So the first one, positive, negative, positive, right? Fifth one, blasting means benzenoid compounds. I will explain you everyone, okay, in a very detailed manner. See, first of all, octet means if you have, for suppose, 1 and 2 resonating structures. For suppose you take one structure and you are drawing a resonating structure to this. Now you have two structures. In these two structures, okay, how you can get to know which structure is more stable? First of all, you have to see octet. So you have to see in this order only. So the order is 1 greater than 2 greater than 3, next to 4, next to 5. Okay, so you have to see every structure like this only. First of all, you have to check the octet. Octet means whether every atom, you have to see every atom of that particular molecule. For suppose I'm checking first structure, right? You have to see every atom of that first structure, whether every atom completed its octet or not, right? So if every atom completed its octet, then that structure is very stable. This is the first one. Okay. Second, you have to see whether it is neutral or not. If the molecule is neutral, that is very stable, then charged molecule. Okay, neutral molecule is stable than charged one. Okay, I will give you examples. Next, third one, negative charge atom. If you have the negative charge, so the negative charge is more stable on more electronegative atom. Positive charge is more stable on electropositive atom, right? Or on less electronegative atom. This is the third one. Fourth one, if you have plus and minus, opposite charges are attracted to each other, so they have to very close to each other. Okay, if you have the opposite charges, opposite charges should be close to each other, and this same charges, minus and minus, plus and plus, they should maintain distance with each other, right? Minus plus, they have to maintain distance. Minus and plus, they have to close to each other. Last one, benzenoid compounds. I will explain you everything in a very clear manner. So the first one first of all, example for octet. So what is the example? So the first example here, I am taking this structure. Okay, double bond, positive. Okay, now I am writing resonating structure for this. Here there is a lone pair, right? Two lone pairs are there. So this lone pair to this positive charge, more electron density to less electron density. So I am getting this structure. I am getting this structure. Here double bond, here double bond, here double bond, and here one lone pair and positive, right? So if you observe, first of all, what you have to see, octet, whether every atom completed its octet or not. So here 1, 2, 3, 4, 5, 6, 7, 8. So if you observe, every atom completed its octet or not. Here see, this is only 6 electrons, 1, 2, 3, 4, 5, 6. So here 6 electrons. So this atom has not completed its octet, right? Here observe 1, 2, 3, 4, 5, 6, 7, 8. So every atom completed its octet, right? Here every atom completed its octet. Here every atom didn't complete its octet. So if I say this is A, this is B, which structure is more stable? B greater than A, right? So you have to see octet. So this is the first example. This is first example. Next, after octet. Next, neutral. Next one, neutral. Neutral is greater than charged one. Neutral greater than charged one. Example, furan. If I take this system, okay, now I have the lone pairs, right? So I am drawing resonating structure for this. This lone pair move to this, right? I am getting this structure. I am getting this structure. Here there is a lone pair. Here double bond. Here negative charge, right? Again I am getting here 1, 2, 3. So positive charge. Now observe. Here oxygen, every atom completed its octet. Okay, you can count the number of electrons. Every atom completed its octet. Here 8, here 8, here 8, 8, 8. Okay, here see, here also, if you observe, here also 1, 2, 3, 4, 5, 6, 7, 8. Every atom completed its octet. So first rule, with the first rule we cannot do anything. We cannot do anything. Now move to next rule. What is the next rule? Neutral is greater than charged one. This is the neutral atom. This is the neutral atom. But even completed its octet, here positive and negative charges are there. So this is the charged one. So which is more stable? Neutral one is more stable. So if it is A, if it is B, then A is greater than B in stability. In stability, A is greater than B. So this is next one. Okay. Next, after this, negative charge should be more on more electronegative atom. I will give you the example for this. Third one, negative charge on electronegative atom, right? Positive charge should be on less electronegative atom. Negative charge should be on more electronegative atom. So what is the example? C, N triple bond C, here H, here O minus, right? O minus. Now I am drawing resonating structures for this. So the first resonating structure, if I move this bond here and this minus will move here. So the first structure I will get like this, N double bond C double bond O, right? Okay. So the next one, again I am drawing resonating structure for this. For suppose now this lone pair will come to this, all right? So the next structure is H N minus single bond C triple bond O, here positive charge, right? Here see, first, so this is the A, now this is B. I am comparing these two structures, right? Here if you observe, here positive charge is there, right? 4 bonds, positive charge is there. Okay, so if you observe, first of all, every atom completed its octet. First of all, check first rule. Every atom in these two structures completed its octet. Okay, so we cannot do with the first structure. anything with the first structure. Second, whether they are neutral, so it is charged one and it is also charged one. It is charged one and it is also charged one. Okay, we cannot do anything. Third rule. What is the third rule? More negative charge should be on more electronegative atom. Here positive charge on nitrogen, negative charge on oxygen. Here negative charge on nitrogen, positive charge on oxygen. So negative charge should be on more electronegative. So here oxygen is more electronegative. Oxygen is more electronegative. So negative charge on oxygen. So this is more stable. So in this two, A is greater than B. A is greater than B. Right? Clear? So you have to go through first rule. Second, third, you have to go like this. Okay? To check the stability. So this is the third one. So after this, fourth one. What is the fourth one? New negative charges. So charges means fourth one. If I have the same charges, if I have the opposite charges, they should close to each other. Okay. If I have same charges plus and plus, they should away from each other. Right? Minus and minus also, they should away from each other. Right? So this is the rule. Now what I have to do? I am taking one example here. So the example here is, first of all, double bond, single here, N double bond O, single bond O minus, here positive charge. Okay, now for suppose here positive, here minus, here positive. Okay, this is first structure. So what is the next structure? If you take the next structure, these two are regenerating structures. Here N double bond O, single bond O minus, here positive. Now here positive, here negative. Observe these two structures. देखो, plus minus conform bond and they are close to each other. Here minus plus conform bond close to each other. Here see, plus minus conform bond close to each other. Plus they repel each other. So but they are close. So this structure is not stable. They should far away to each other. Plus and plus, they are close to each other here. So this is not stable structure compared to this. So for suppose it is A, it is B. So first structure is more stable than B. Right? A greater than B because same charges are close to each other. This is not stable. Next. Next. Last. Blasting. Benzenoid compounds. Benzenoid compounds means benzene ring. The compounds which are having benzene ring. So what is this? For suppose I am taking anthracene structure. Anthracene structure. So I am taking this structure first. Anthracene. Okay. I can write the same structure as. I can write this same structure as like this. I can write the same structure as like this. Okay. So if you observe clearly, this is structure A, this is structure B. In these two structures, I have here two benzene rings. The first benzene ring is this, second benzene ring is this. Dekho, if you observe clearly, the first benzene ring is this part. Okay, this is first benzene ring. Second benzene ring is this one. Second benzene ring is this one. So I have two benzene rings in the structure. This is also anthracene. But if I write same anthracene like this, I have only one benzene ring. Right? So whenever you have more benzene rings, stability of that particular molecule is very, very high. So that B is greater than A. B is greater than A. So this is about the stability of the resonating structures. Okay. So if you observe, if you remember this order, okay, that is sufficient to do the questions on stability. Okay. Next, important thing, in the last class I have discussed about the mesomeric effect. Mesomeric effect is nothing but resonance effect is nothing but mesomeric effect. So this mesomeric effect is of two types. One is plus M type, second minus M. That is plus mesomeric effect and minus mesomeric effect. I have discussed the examples. One with electron donating group. If you remember, in last class I have discussed this example, right? I have discussed this example, aniline. Okay. Second example, I discussed this also with COOH, right? If you observe, This is electron donating group. This is electron withdrawing group. Okay, so whenever electron donating group will participate in resonance, right, that is nothing but your plus M group. This group is nothing but your plus M group. Whenever electron withdrawing group will participate, this group is nothing but minus M group. So this is plus mesomeric effect, this is minus mesomeric effect. Okay, plus mesomeric effect and minus mesomeric effect. Second, in inductive effect, I said you, inductive effect is distance dependent. That means distance is inversely proportional to the inductive effect. I already said this, right? But whenever you come to mesomeric effect is distance independent. Okay, so what is this distance independent? I will explain you clearly by questions. Okay, I will explain you questions in lateral classes. You will get to know what is distance independent. Okay, so this is one thing. And last important point, what is delocalization? Delocalization means the movement of electrons from one place to another. Okay, if the movement of electrons are not there, that is localized electron, localized pi bond, localized lone pair. If lone pair will move from one place to another, for suppose C double bond C, single bond C, or single bond NH2, for suppose like this, right? So here there is a lone pair. So lone pair is participating in conjugation. So this lone pair is moving, this double bond is moving. So these electrons are delocalizing electrons. Okay, so these are some important points of mesomeric. So this is about today's class. Okay, this is about the tricks. These are very, very important. Next classes are also on stability of the molecules. Okay, so that's all. If you have any doubts, please ask in the comment section or you can mail me. Okay, so that's all. Thank you so much. Have a great day.